Hello there, ladies and gentlemen. We're back again with some more total value problems that we're going to be solving. The problems we're going to look at today are all going to be what I like to call inferred value, where basically they expect you to know the value of the items they're talking about, so they're not going to give you that information. So yesterday we tell you, hey, adult tickets are $20 and kids are $15. This is $7 and this item is $2 or whatever. In this instance, they're not going to tell you that. They expect you to know it. So for example, one thing they'll do this with is with change in money that we already know. So in this problem, Lindsay has 15 quarters and dimes in her pocket. When she counted her change, she had $2.70. How many dimes and quarters are in her pocket, okay? They're expecting us to know what the value of a dime and a quarter are, and luckily enough, we do know that, okay? So let's start by identifying our variables. In this case, we're going to have 2. We're going to have Q, which is going to be the number of quarters, and then we're going to have D for the number of dimes, okay? So Q for the number of quarters. My mouse is getting stuck there. Okay, number of quarters, and then we're going to have D for the number of dimes. Once we have our variables listed out of the way, we then can go ahead and move on to our equations, which again, we're still going to have a total, and we're still going to have a value. My total equation is going to look very similar to what it did yesterday. I take the number of quarters, I add on the number of dimes, and I'm going to get the total number, which is 15. The values where I have to kind of use some of the stuff I know already before I go to write this out. I know a quarter is worth 25 cents, and I know a dime is worth 10 cents. So I'm going to say, all right, 0.25 for a quarter plus 0.1 times a dime is going to equal the $2.70. And now I'm going to go ahead and I'm going to solve this. Here's an example where I'm going to want to use clearing out the denominator as a strategy to solve, okay? Notice how I have these decimals. I don't want to deal with decimals, so I'm going to multiply every term by 100. And what that's going to do is that's going to move all my decimal places to the right twice, and that's going to make it so that I don't have decimals anymore, and I might have an easier idea of what I want to do. So I'm going to get 25Q plus 10 for the dimes equals 270, okay? Now, I'm going to, again, use elimination for this, so I'm going to take this top equation and multiply it by 10 each term. So I'm going to get 10Q plus 10D equals 150, okay? And now you can go ahead and subtract these from each other and go ahead and do my elimination. These are going to cancel out. And I'm going to I'll write it over here. I get 15 quarters is going to equal 120. All right. And then I'll go ahead and divide by 15. Divide by 15. And I'm going to get my number of quarters equals 8. Okay. So in Lindsay's pocket, she has 8 quarters. And if she has 8 quarters, we can go ahead and put that into this equation. So 8 quarters plus my dimes needs to equal 15. I get to subtract 8 from both sides, and I'm going to get that she has the dimes that equal 7. So 7 dimes and 8 quarters. And again, I can check that and make sure it actually makes sense over here. If I put in 8 and I put in 7, 8 times 0.25 is going to be $2. 7 times 10 cents is 70 cents. $2 plus 70 cents is $2.70. This is going to be the right answer. This works out, okay? Solving for my number of quarters and my number of dimes. Next problem here, we have Colleen's Bike Shack that sells bicycles and tricycles, okay? So she has a store that's selling bikes and tricycles. Again, we are expected to kind of know, as you're going to see in this problem, how many wheels a bike has and a tricycle has, okay? They sold 40 items from the store. She had to make 100 wheels for all the items. How many bicycles and tricycles did she sell? Again, we're going to start by writing out a variable. So B is going to be the number of bikes. And I'm going to use T for the number of trikes. Okay, and that's going to go ahead and lead us into our total and our value equations. Again, our total equation's not going to look very different from yesterday. Really, neither of them are, but we can use the exact same method from yesterday. Okay, well, my bikes plus my trikes, that needs to add up to 40. That's how many total that I sold, okay? Whereas for the other one, for the wheels, again, I need to know how many wheels a bike has and a tricycle has. In this instance, there's 2 wheels on a bike, and there's 3 wheels on a tricycle. Again, hopefully she's selling good quality and she's not selling me one-wheeled bikes. That would be a mess, right? Okay, so that's what we have here. Now I can go ahead and solve just like I would have any other day. In this case, again, I'll use elimination. Multiply by 2. I'm going to get 2b plus 2t equals 80. To be or not to be? That's the question, all right? We'll go ahead and we'll subtract these. Cancel over here. I'm going to get that t equals 20. So she sold 20 tricycles. And we go ahead and plug that in back up here. B plus 20 should equal 40. Subtract 20, and she sold 20 bicycles. Okay, and that makes sense. If we go back, we think about the problem, we plug it back in here. 2 times 20 is 40, 3 times 20 is 60, 40 plus 60 gives me 100. So 100 wheels would make sense for this order. Again, they don't tell me how many wheels are on a bicycle and a tricycle. They expect me to know that coming in, okay? Here's our last example. We're on a farm, and we know that there's 20 total chickens and cows. For some reason, the farmer went out one day and said, hey, I'm going to start counting how many legs my animals have, and he counted 50 legs. We want to know how many cows and chickens are on the farm, okay? Now, of course, we're assuming that none of these animals have lost any legs. They're all fully limbed. Okay, but if we assume that, we can go ahead and we can write our total and our value equation, okay? So when I go to look at this, I'm going to use C for my number of cows. Now you're going to see I'm going to run into a problem here because for chickens, I definitely don't want to use C again, okay? So I'm going to go ahead and I'm going to use N for chickens. And I'm using N for chicken nuggets. Who doesn't like chicken nuggets, right? So we use N. Again, you can always use any variable that you want, okay, for anything. Just make sure you label it, and everybody's going to be good to go. Okay, total equation. Once again, it's going to be my number of cows plus my number of chickens is going to equal 20. I know I got 20 animals on my farm. In terms of my value equation, all right, well, how many legs does a cow have? Well, I think a cow has 4 legs, so it's going to be 4 times the number of cows. How many legs does a chicken have? I'm pretty sure they have 2. So it's going to be 2 times the number of chickens, and that should equal the 50 legs that I'm counting, all right? Once again, I'll use elimination. I'll multiply this top one by 2. So I'm going to get 2c plus 2n equals 40. We'll go ahead and we'll subtract. I'm going to get 2c equals 10. Divide by 2, divide by 2. There's going to be 5 cows on the farm. If there's 5 cows on the farm, we can go back to our total equation and solve for the number of chickens. I'll just subtract 5 from each side. And I'm going to get that there are 15 chickens on the farm. So we're a farmer, we got 15 chickens and 5 cows on our farm. Again, assuming they have 4 legs and 2 legs like they usually do, okay? So again, they're not telling me what the value is, but I know it from information that I already know, and I can then bring that into the problem to get my total and my value equation, okay? So that's some more total value equations. Again, some more practice like we did the other day. Thank you all for watching.